Today we're going to learn how to take a fraction and pull it apart into the pieces that formed that fraction. And what we call this is finding the partial fraction decomposition of the fraction. So in essence, we want to take the fraction that we have here, split it apart, and know what fractions did we add together to get this one. So there's a couple of different scenarios that we can look at. The first one that we're going to look at here is how to do it when we have factors that are linear factors down in the denominator. And we could have these factors multiplied together or not. Ultimately, we're going to want to see what those factors are, so we're going to want to factor it out if they were multiplied together. Now, in order to find this decomposition, the first thing I'm going to do is split this apart into at least two fractions here because I have two different pieces to the denominator. If I had more pieces, then I'd create more fractions. So I can say that I've got this 7x minus 7, the original fraction, over x minus 5, multiplied by x plus 2 in the denominator, equals some unknown value over the first factor of x minus 5, plus a second unknown value over the second factor of x plus 2. So when I have linear factors like an x minus 5 or an x plus 2, I can just put a single variable, an a or a b or c, depending on how many fractions I need, up in the numerator. And our goal is to figure out what values were a and b to make this fraction get to the 7x minus 7 up in the numerator. So what we're going to do here is we're going to take this entire thing and I'm going to multiply this by the original denominator, which was the x minus 5 and the x plus 2. And now in doing this, we're clearing out the denominator so that we don't have any fractions anymore. So if I take the x minus 5 and the x plus 2 and multiply it to that first fraction, both of those factors are going to cancel out, and I just get the 7x minus 7. If I distribute both of these factors in red to the second fraction, the x minus 5 will go away, but the x plus 2 will not. So I've got a times the x plus 2. And then if I multiply both of those factors by the third fraction, the x plus 2 will cancel out or divide out, but the x minus 5 will not. So I have this new equation that no longer has fractions that we can use to help us to solve for a and b. Now in order to do that, I'm going to distribute in the a and the b on the right side of the equation here and get ax plus 2a plus bx minus 5b is equal to that original numerator of 7x minus 7. And then I'm just going to rearrange this so that my common terms are together. So I get 7x minus 7 equals, I'm going to put the ax and the bx next to each other because they both have x terms. And then I'm going to reorder this so that the 2a minus 5b is together because those two don't have x's. So now looking at these, this 7x term here is some combination of the ax and the bx. And then I could also say that the negative 7 is a combination of the 2a minus 5b. So if I were to add the ax plus bx, that should give us 7x, and 2a minus 5b should give us a negative 7. So I'm going to form two different equations that can help us to solve a system of equations so that I know what a and b are. So those two equations, one of them I could say is 2a minus 5b is equal to negative 7 using the terms that didn't have an x value. And I could also say that a plus b is equal to the coefficient of the x, which is 7. So I have these two equations formed by grouping the terms that had x's and grouping the terms that didn't have x's. And now I'm going to solve this using either substitution or elimination. Probably, in my opinion, this one's going to be best solved using elimination. So I'm going to multiply that top equation by 5 so that I can add the two equations together. So I get 5a plus 5b is equal to 35. And then I can copy down the bottom equation as it was. And then if I add these two equations together, those b's are going to subtract out. And I get 7a is equal to 28. So then if I divide off the 7, I end up getting a equals 4. So I know that the original a value from that first fraction was 4. And if I look back at this first equation of a plus b equals 7, I can use that to help me to solve for b. That's going to give me b is equal to 3, because 3 plus 4 is 7. So then I know a is 4, b is 3. What good does that do me? Well, let's look back at the original fractions we had up here. I had these two fractions with an a and a b in the numerator. So if a is 4, that means my answer here, I'm going to say is 4 divided by x minus 5 plus the b value was 3, so I can say 3 divided by x plus 2. That is my partial fraction decomposition for the original fraction we had. If we were to add these two fractions together, we would get that original 7x minus 7 over the two factors fraction. That is our goal when we're doing this partial fraction decomposition.